Assalamu alaikum. Welcome to the CSITEd Experts Data Science A to G Bootcamp. I am very much excited that I am almost ready in my pre-processing steps, and in the previous video I showed how to split a data set into a training set and test set, and with that knowledge in mind, in this video I will discuss how to develop a linear regression model, and this will be our first model, machine learning model. So I'm very excited you at this point, and let's get started. So if you do a Google search and search about linear regression model, then you will see this kind of images, and for images, this is a linear regression model line, a linear. So by meaning linear regression, we mean that we will develop a line. So we will develop a standard line that will help us to understand some correlation, a correlation between one or more independent variables and a dependent variable. So if you understand linear regression, then I think it will be easy for you. But let us explain. Let me explain what do I mean by independent and dependent variables. So let me open my program. So here, let me clean everything, and let's get started. And let me make sure that you got my data science A to G this project, and it has regression and folder, and it has simple linear regression this folder, and select this folder. Okay, and then open, you will see this program. So these are the simple linear regression model programs with Python. So this is the first one I am going to discuss. Okay, so I already opened this. Okay, so in this program I have used a data set. This is my data set. So let me get my libraries and data set. So I have my data set. So in this folder I have a experience salary data set CSV file. So this is my, in this file I have experience salary data set. So this is a very simple data set, almost the previous data set, and it has only one independent variable, that is the experience, and the salary is my dependent variable here. So independent variable means, so based on an employee's, think about in this way, based on an employee's experience in year, his salary, annual salary, will be calculated. For instance, if this is a simple salary sheet of a company, so this for instance, this company has about 50 new existing employees, or 50 employee information, and these are their rough information that a person, these employees, their employees have this number of experience, and this is their annual salary. Okay, so based on their experience, their annual salary depends. Some for more it says more experience employee earns more annual salary. Okay, so here experience is my independent variable and salary is my dependent variable, right? Okay, so and here, so this is my data set. I have my this is first column with index 0, and this is my second column with index 1. Okay, so I have 50 rows and 2 columns. Okay, so here actually my x, remember that when we define x in uppercase, that means it is a matrix, or always we, in our programming convention, we always will define a matrix with an uppercase letter, and when you see a lowercase, that will be a vector. Okay, that will be a vector over here. So my x is a, so from my data set, let me extract my vector, my matrix, independent matrix. So here my independent matrix is very simple. So it is only one, it has only one column, right? Only one column. This is my independent column. So at this point, please give some attention. If you understand this, then you will be, it will be very easy for you to understand the remaining part. Okay, so I'm using ilog, and then for all rows and only the first column, so 0, colon 1, that means since 1 is excluded, so then I will get only the first column with column index. Okay, so that will be my x matrix. So if I will get, then you see that I got my x as a matrix, so it has 50 row and 50 rows and 1 column. Okay, so remember that I cannot do this way, I cannot have this, since my, this is, if I do this way, for instance, let me give a different name in order to explain you. So if I go this way, so what, it will not work, because in this case my x1 is a vector, but we need a matrix. Okay, we need a matrix. So this is why I need to put this way, so to make a matrix. Okay, I got my matrix. Then my y is a vector over here. So my vector has, this has only one column. So this, so since it's a vector, I can have both way. I can use this way, or I can use this way. Okay, so here it will get only first column, only second column with index 1, and but this way it will get also second column. So let me run this. If I run this, you see that y, my y, I got y as a matrix. Okay, I got y as a matrix, but if I would use this way, then I would get, let me rename it as y1, my y1, I would get y1 as a vector. Okay, so but in this case I need to use, I can use both maybe, or I can use, I need to use this way. Okay, so my x and y, will be here both two matrices here, although we put in lowercase, it is a matrix over here. So x, my x is my experience, and my y is my annual salary. Okay, so now what we want to do, we want to draw a linear regression model. We want to draw a correlation line, for instance, like this, simple like this way. Okay, once we developed a line, so then similar way, this is not exactly that. For instance, when we are given an employee's experience, then so that we can predict pretty accurate annual salary. So let us, before that, so okay, so if I run my entire program, actually we want to develop like this. By the end of this video, this lecture, you will see that we will develop a model like something like this. For instance, on the x-axis it is showing years of experience, and for the and y-axis it is showing yearly salary. So then if I am given a year of experience 4, then I can predict that annual salary will be about 63,000. And if person has a 10 years of experience, then annual salary will be about 123 years 23,000 per year dollar. Okay, so this will be my goal at the end to develop. So but let me go through step by step and explain, close everything. Okay, so let me run this. So I got my x and I got my y. Okay, so I got my x matrix and I got my y matrix. Okay, so now if I do a scatter plot, you will see that I got my this scatter plot is not a straight line, but we want to develop a straight line that is pretty is straight and that covers almost all of our data. So these blue dots are our data. Data means year by salary. Year is going by x-axis and salary is going by y-axis. For instance, like this. For instance, 0, 39, 3, 56, like this way. Okay, so here now you know that in our previous video we discussed how to get our what is that one, how to split data set into training set and test set, right? So we already know that. So here at this lines of code we have set up training set about as 80% of our data and test set as 20% of our data. So as I discussed that, since training TRAINING, it takes 8 characters to type in training, so then 80% of our data will be in my training set. This is a good way to remember, and I believe you will get a lifelong lesson. You will never forget that. And then the sum of our test set and training set will be 1. So if I select my either test set or training set accurately, then another one will be calculated accordingly. Okay, so if I do that, if I select test set as 20%, then my x test is 20% of my 50 data, that's 10 data is my test set, and I got my training set equal to 80% of 50 equal to 40 data as my training set. These are set up randomly, not intentionally. So similarly, if I select here as training size as 0.80, then my test size will be automatically 0.20. So my y train is 80% equal to 40 and my y test is 20% equal to 10 data. Okay, so now this is the 3 lines we need to use. So in order to build a linear regression model, we use linear regression this class. Okay, so we will import this class from sklearn. This means scikit-learn. Okay, I could give this statement at the beginning, but I gave here, I put here so that we can go through step by step. Okay, so from sklearn linear underscore model, we will import linear regression. Remember that L and R are uppercases, so this is a class name. Okay, so from the linear regression we imported this nicely. Then we will define a variable named regressor. Okay, so my regressor equal to, so we will call the linear regression, this is a constructor. So how do we know? A constructor is a method of a class that has exactly same name of a class with a pair of parentheses at the end. Okay, you should know it. If you know object oriented programming, this is know. Then what we will do, we will use my regressor dot fit method. So if I inspect my fit method, you see that the fit method, it fits, it says x, y, and so if you go through this, then my fit method, I need to put x is my matrix, data matrix is x train, and in y will be my y train. So my fit method will be y train over here. So in another video I will discuss more in detail how to develop this regressor. Okay, but shortcut in this video I'm going quickly, so I will click my regressor. Then once I develop my regressor, for instance, if I want to print my regressor, what it will see. So if I want to print, or quickly I can actually control C copy, and I can see control V. You see that it is a model, I cannot print it. It is a model that I cannot print it. Okay, so it is not a value, so I cannot print it. Now what I will do, I will use my predicted value. I will calculate my predicted value using regressor dot predict method, and within the predict method I will supply my test matrix. Then if I do this, okay, so then it's good, I have created my y predicted okay, predicted variable. You see here, I got my predicted variable as another what is here, my variable here as a matrix, right? So I got my matrix, predicted matrix. Okay, so now if I do a scatter plot this, okay, so then you see that this is my regressor, this red line is my regressor line. Okay, so the red line is my regressor line, that means, and these are the blue dots are each of my training data set. So that means this red line is my machine learning model. It becomes a machine learning model, that this line this is a tool for me. So, okay, so this line will allow me to what, to predict any employee's annual salary when we know his year of experience. Okay, so this model is developed completely based on the training set. You see that I have x train and y train value. So this model, actually this model is developed based on training set data. What was my training set? I got my 80% data as a training set data, right? Now what I want to do, I have my remaining test set in hand, right? I have my 20% data, I splitted and kept aside as my test data. So what should I do with that test set? Now actually what I will do, I will justify my uh, uh, model's validity with that test data. I will verify how good my model is based on that test data. So if you remember that, so now I will justify my model whether it is accurate, how accurate, with this remaining test data. So if I do a scatter plot, okay, build a scatter plot, and you see that I have my 10 1 2 3 4 5 6 7 8 9. I have exactly 10 data points over here, and according to these data points, my model, same model, I created that with training. You see that I put same xtrain and xtrain over here, okay, and I plot same training, my training model, my model, and but I justified with my test data here, but previously I had my train data. So now it looks that if I have now if that means it looks that my model is pretty accurate and this looks good. So then, so if I know that a person's uh, ex experience is 3 years, then I can predict that his annual salary will be about 50, around 50,000, okay, $1,000 per year. So if we go through that in our data set, so that you can see that if a person has about 3 years experience, 3 and something, that about 40 or $50,000 per year. So this means that our model is pretty accurate. But since this is a very simple, this is the simple linear models, linear regression model, so this might not be accurate. So we will see that later we can develop our own regressor, okay, and we can develop better linear regression model. So here in this case, one thing that we used the built-in library, this built-in library, okay. So this linear model library from sklearn, okay, sklearn libraries, this library we used in order to develop our regressor. But later in my later video I will show how to create our own regressor at, but before that you need to learn, you need to know about some foundational knowledge of linear regression and linear algebra and vector analysis. But in the theory section we will discuss that separately in depth, but in our programming section we will go through this quickly. But I believe so this will give you an attention or impression that now at this point we got something to visualize, and we will get a confident that we are at the beginning of learning machine learning model and big data analysis. So please do some practice, and in our next videos I will show you more impressive machine learning models. Thank you so much. Thank you for watching this video.